Okay, so this is our last of the transformations, and then we're going to put them all together. Okay, so it's called a horizontal stretch or compression. So let me make up a little function here. Let's say I have the point 0, 0, 2, 2, and 4, 0, okay? And it's just this little function like that, okay? And I'm going to call my function f of x. So then when I want to do a horizontal stretch or compression, I'm going to say g of x, let's say g of x, is equal to f of, let's put in 2x, okay? Now what that means then is I have 3 points here, right? I know f of 0 is 0. I know f of 2 is 2. And I know f of 4 is 0. That's all I know, okay, from my little graph. So if I want to have f of 0, what would x have to be? 0, right? So g of 0 would be f of 2 times 0, which is f of 0, which is 0, because we know that from there. Okay, so that point is the same. There it is. Now, if I wanted f of 2, I would need to put in a 1 for x. So that would give me f of 2, and I know f of 2 is 2. So then now I have the point 1, 2. Okay? And then finally, if I wanted f of 4, I would have to put in a 2 for x, right? To get f of 4. So I'm putting in a 2 for x, and that's going to give me 0, right? 2, 0. So now my graph, my f of x that was like that kind of teepee thing, now it's going to be squished or compressed into half the space. So all the points moved horizontally by a half. So all my inputs were cut in half with the same outputs, okay? So what used to be 2, 2 was now 1, 2. And what used to be 4, 0, I'll write this over here. So that point that was at 2, 2 for the g function becomes g of 1, 2. And the point for g, or for 4, 0, that becomes g of 2 equaling 0, okay? So you're squishing, it's like an accordion. You're squishing them together. So you get a compression. So when you have g of x equals f of k, that's a k, x, it's a compression if k is greater than 1. So probably opposite of what you're thinking. Okay, now let's do the stretch. So let's go back to our little function we have, and maybe we can have a better function. I'll just do the one we had. Okay, so there it was. But now we're going to say g of, so f of x was the same from above. Okay, that's f of x. Messing this up. Need to get some lunch. Okay, g of x, we're going to make that f of 1/2 x. Okay, so now, like, I kind of would have to scroll back up here. Let me just rewrite them. Remember, we had f of 0 equaling 0, and f of 2 being 2, and f of 4 being 4, or 0. Okay, that's what we had. So now, if I want to get f of 0, I have to have 1/2 times 0, right? So that means I'm putting in a 0, and f of 0 is 0, so that point stays the same. Okay, now if I want to find g, well, I want it to be f of 1/2, but I want it to be a 2. So I'm going to put in a 4, so that when I take half of it, I'll get 2. And then that gives me f of 2, and f of 2 is 2. So I get the point 4, 2. And then finally, if I want f of 4, I'm going to have to put in an 8. So then that gives me f of 4, and that's going to be 0. So that's going to be like way out here someplace. So I'm getting a stretch here. This is going to be a horizontal stretch. And that happens when we have g of x equaling f of k, some constant, times x. But now k is between 0 and 1, okay? All right, so it's kind of opposite of the vertical stretch and compression. All right.